Notice this expression right here. All four of these parameters, A, B, C, and D, are assumed to be positive. So what is the condition for the equilibrium quantity to be positive? What must occur in order for the equilibrium quantity to be positive?
A, B must be bigger than B, C.
Exactly. If you just look at this formula right here, Q star is equal to AB minus BC over B plus D. Now, as long as AD is greater than BC, then this numerator is going to be positive. So this is greater than 0 if AD is greater than BC. Now, typically, this parameter A, typically that'll be bigger than C. So generally, this will be satisfied. But there are cases where it might not be satisfied. Let me just make up an example where it's not satisfied, where the equilibrium quantity is not actually positive. Consider this case right here. Actually, I gave a problem like this once on a quiz, just to see what the students do. Suppose quantity demanded is 100 minus 5p. So for this demand function, the vertical intercept is 100, the slope is minus 5. Okay, so it's a nice downward sloping demand curve. Let the supply curve be this equation, minus 20 plus p. If we just solve for this directly, in equilibrium, Q equals QS. So we could say in equilibrium we'll have 100 minus 5p equals minus 20 plus p. Add 5p to both sides, add 20 to both sides. We get 120 equals 6p, and p star equals 20. Well, if the equilibrium price is 20, then go to the demand curve, substitute in that price, and you get the equilibrium quantity is 100 minus 5 times 20. 100 minus 100 is 0. So if I haven't made a mistake, it looks like the equilibrium quantity is actually 0 here. Let's see what this looks like in a picture. In a picture, it looks like this. Vertical intercept of demand is 100. Slope is minus 5. So it comes down. Where will this demand curve cross the horizontal axis? Yeah, at 20. Notice if the price gets up to 20, quantity demand is actually 0. So we could say 20 is the choke price. It's a price so high, makes quantity demand 0. So that would be this horizontal intercept right here. What's our supply curve look like? Well, it starts at minus 20, has a slope of plus 1. So the supply curve looks like this. And it just intersects the demand curve right at this choke price of 20. So indeed, this is the right answer. In this case, the equilibrium quantity is actually 0. So what would actually happen in this case? What would it mean if the equilibrium quantity was 0? How much would producers produce? How much would producers produce? Yeah, then nothing. So actually, if the producers were not producing anything, you wouldn't actually observe this market because they wouldn't be producing anything. So this market really, you wouldn't even observe. Now, suppose I redo this problem. Notice in this case, the slope of the domain curve is -5. Suppose I make this slope of the domain curve -10. Then the domain curve would look like this. We'll call this D prime. Then where would the equilibrium quantity actually be? Well, positive or negative? It'd actually be negative, because you can see if I made this domain curve even steeper, the equilibrium would occur down here at a negative point. Of course, you can't, in economics, you can't have negative quantities. So what that actually means is you wouldn't observe this market. The price is just not high enough to get producers to produce this product, so you wouldn't even observe it. But in terms of the simple mathematics, you could have the domain curve intersecting the supply curve at a negative. And notice that's consistent with our answer for the general solution. Q star equals, what was it, AB minus BC over B plus D. If you just plug in these values, let's change this to a -10. Into this formula right here, what you get is Q star is 100 times 10. D is 10. Minus.
Would it be 1? D is 1. B is 10.
Oh, you're absolutely right. Thank you. Thank you. B, excuse me, B is 1, but D is, B is 10. D is 1. Yes, thank you. Absolutely right. Minus, now, here our B is 10 times C, which is 20. Now, what is B plus D here? 10 plus 1 is 11. So you do this math, you get 100 minus 200 over 11 is minus 100 over 11. So that would be what, about minus 9.9 something. So you actually would get a negative quantity in this case. And that would be this intersection right here. Now, typically, the demand curve will intersect the supply curve in this region where quantity is positive. If it intersects down here in this region, then you wouldn't actually observe this one. Any questions on that? It's kind of interesting. I know this is a simple model, but if you push it to its extreme, you can come up with some interesting questions and interesting results.